hello again guys. For today, we are about to present to you the lab experiment number 5, which is entitled the series connected resistances. So watch the whole presentation.
Yo, yo, yo. Yeah. Mic check. Yeah. Wait. Gumagana ba tong mic?
Hi guys, this is PJ and today I'm about to present to you the objectives and the materials used in this experiment. So the objectives of this lab experiment is to verify the principle that governs resistances which are connected in series. And the materials or apparatuses used in this experiment is the FET simulator, specifically the Circuit Construction Kit DC. So once again guys, this is PJ, your cutie little Einstein number 1. Charot lang. So again guys, I'm here again because I'm the one who will be presenting the diagram. So for the diagram, here are the diagrams that we captured in the lab experiment. Trial number 1, trial number 2, and trial number 3.
Yo, yo, yo. Yeah. Mic check. Yeah. Wait. Gumagana ba tong mic?
Hi guys, this is Bellaflores to tell you the procedure for this experiment. First, click and drag the circuit components from the sides to get them into the work area. The series circuit will only need 2 resistors. Second, to measure the current flowing through a circuit and all of its components, 3 ammeters must be placed in the circuit, meaning the current flowing through the circuit must pass through the ammeters. Third, to measure the voltage supplied to a circuit component, 2 voltmeters must be connected across the component. Click on the resistors to change the resistance value in the experiment. The values of the resistors from each trial must be different from each other, from the first trial to the last one. The values of the resistors must be in an increasing manner and the voltage must be kept constant.
So once again guys, this is Bellaflores, your cutie little Einstein number 2.
Yo, yo, yo. Yeah. Mic check. Yeah. Wait. Gumagana ba tong mic, Mel? Gumagana.
Hi guys, this is Mirador to present the table in this experiment. On the first trial, we have R1 with a value of 13, R2 with a value of 16, and RT with a value of 29. I1 and I2 and IT with the same value of 0.34, V1 with a value of 4.48, V2 with a value of 5.5, and VT with a value of 20. On the second trial, we have R1 with a value of 15, R2 with a value of 19, and RT with a value of 34. I1, I2, and IT with the same value of 0.29, V1 with a value of 4.41, V2 with a value of 5.59, and VT with a value of 20. On the third trial, we have R1 with a value of 17, R2 with a value of 21, and RT with a value of 38. I1, I2, and IT with the same value of 0.26. V1 with a value of 4.47, V2 with a value of 5.53, and VT with a value of 20. So once again guys, this is Mirador, your cutie little Einstein number 4.
Hello guys, this is Mrs. M. Guardamano to present to you the computation of this experiment. So hello guys, as you can see in our table, there are 3 trials. The numbers under the R1, R2, I1, I2, IT, V1, V2, and VT are the numbers that we encoded, while the numbers under the RT or the total resistance are the numbers that we computed. To get the value of the total resistance, we simply add the R1 and R2. For trial number 1, 13 plus 16 equals to 29. Trial number 2, 15 plus 19 equals to 34. And lastly, for trial number 3, 17 plus 21 equals 38. So once again guys, this is Princess M. Guardamano, your cutie little Einstein number 5.
Yo, yo, yo. Yeah. Mic check, mic check. Yeah. Wait. Gumagana ba to? Gumagana ba tong mic, Mel? Gumagana.
This is Florex from Magcanam and John Lawrence Layda to give our discussion and observation in this experiment. When the flow of charge or current must pass through components in a specific order, resistors are used in a sequence. Since the current must pass through each resistor in the circuit in order, the total resistance in the circuit is equal to the number of the individual resistances. When the resistors are daisy chained together in a single line, they are said to be linked in series. Since there is no other direction from the current flowing through the first resistor to go, it must also travel through the second, third, and so on. Then, since the current that flows through one resistor must also flow through the orders because it can only take one direction, resistors in the series have a common current flowing through them. Value of current will remain constant in this experiment. The first and second resistors in the first trial have values of 13 ohms and 16 ohms respectively, for a total resistance of 29 ohms. Using the Ohm's law, the first resistor's measured voltage is 4.48 volts, while the second resistor's measured voltage is 5.5 volts, for a total voltage of 20 volts. In the second trial, the first and second resistors have values of 15 and 19 ohms respectively, for a total resistance of 34 ohms. Using the Ohm's law, the first resistor's measured voltage is 4.41 volts, while the second resistor's measured voltage is 5.59 ohms, for a total voltage of 20 volts. In the third trial, the first and second resistors have the values of 17 and 21 ohms respectively, for a total resistance of 38 ohms. Using the Ohm's law, the first resistor's measured voltage is 4.47 volts, while the second resistor's measured voltage is 5.53 volts, with a total voltage of 20 volts. So once again guys, this is John Lawrence Layda.
I'm Florex Mark Magcanam, your cutie little Einstein number 6 and 7.
Yo, yo, yo. Yeah. Mic check, mic check. Yeah. Wait. Gumagana ba to? Gumagana ba tong mic, Mel?
Hello everyone, today I will be discussing our conclusion for this lab experiment. To sum up everything that has been stated in this lab experiment, we have concluded that when resistors are DC chained together in a single line, they are said to be linked in series. In series connected resistance, the value of each resistance is not equal to one another. It doesn't matter how far or how near the resistance to the battery is, because the value of the voltage in each resistance is dependent to the value of the resistance and the value of the current. So once again guys, this is Neil Anthony Cubid, your little Einstein number 3.